Hey, welcome to this lesson video for properties of logarithms. This time we're going to go the condensing direction. The previous video we did some expanding, so let's just do a quick recall. Last time we had something like this. Log base 7 of x squared divided by y. To expand this, remember we break up multiplication with addition, division with subtraction, and we bring powers out front. So expanded form for this guy would be 2, because the power comes out front, 2 log 7x minus, because of the division, log 7y. Okay, so this is expanding our logarithmic expression. We also looked at something like this, maybe log base 5 of 3x to the 7th. This guy's expanded form, break up multiplication, realize that 3 and x are being multiplied. So I want to break up that multiplication by adding log base 5 of 3 plus log base 5 of x, but because x had a power, remember that actually goes in front of that log. Okay, so this would be his expanded form. One other thing that we looked at when we had, let's say the cube root of z squared. What would this expanded form be? Well, the first thing we talked about was making the root house into a fraction exponent. So making it 2/3 as a power. And then we know how to handle powers. Powers go out front. So the final expanded would be 2/3 out front, log 4z. And this would be the final expansion. Okay, so when we're talking about condensing, we're just going the opposite direction. I give you what's already expanded, and we take it back to the original single log quantity that we would have started with last time for expansion problems. Okay, so let's look at this first example. Why is there a 4 out front? Because it was a power, so we've got to put it back. However, this quantity, 2x, gets raised to the 4th, and so then we just want to make sure that we distribute that power. So 2 to the 4th is 16, x to the 4th is simply x to the 4th. Okay, so notice the directions say, write the expression as a single quantity. So here's a single quantity. I only have one x, so I know I'm completely condensed. We look at another example. Why is this 1/3 out front? Well, originally it was an exponent, but why is that exponent a fraction? Because it was a root house. Okay. Oh, and by the way, this is lowercase ln, just a natural log. Another type of a logarithm. Our properties of logs still work the same. Okay. We just need to remember what this fraction means. It means power over root. So I got to put those numbers back. So the root was a 3. Power of 1 is understood, but if you like a visual, I mean, it's understood to be there. Okay. Next one. I think it would be wise to first put the powers back on y and z. Whoops. So we would have log 5y cubed minus log 5z7. And then we need to ask ourselves, because we're supposed to write it as a single log. Right now we have a log minus another log. Why was there subtraction? Because originally there was division. So notice how I write this. Log 5 followed by the fraction bar. Do not, extend it to where log 5 is at the top of a fraction. No, it goes log 5 with the fraction bar following, y cubed on top, z to the 7th on the bottom. And this would be the final condensing. Okay, let's look at another one. I think I would start strategically. If you think about PEMDAS, it says parentheses first. I think that would be wise to do that here. Start with these brackets and ask yourself, why are those two things added? Because originally 3 and y were multiplied. So we have the natural log of 3y. And maybe I'll write these like a cursive L. There we go. Okay. So the next question, why is this 2 in front of this natural log? Well, it was a power, so we just gotta put it back. Actually, let's just take care of both of them. So the natural log of the quantity 3y needs squared, and z needs raised to the 4th. Okay. So we just want to make sure that we distribute this square just to clean up our answer. So we really have natural log 3 squared is 9, y squared, okay, minus natural log of z 4th. And then we still have 2 natural logs, and I want to write it as a single. So ask ourselves, why do we have subtraction? Because there was division. 9y squared divided by z to the 4th. And this would be the complete condensing. All right. Let's get this guy out of the way. Let's see. Why is this 1/2 in front? Because it was a power, so let me put it back. Log 6. It was a power on the quantity of 3x. Okay. Same thing with this 4. Might as well just go ahead and do it real quick. Let's move it as a power again, so y to the 4th. But let me go back to this guy. Why does he have a fraction power? Because it was a root house. Okay, it was a radical. So 3x goes inside the house. Now remember, power over root. So the power is understood to be a 1. You can write it, you don't have to. If you need to see it, that's where it goes. The root also, you don't need to write it. What 2 is understood to be the root. But just so you can see the breakdown, that's where that fraction goes. Okay. Now last question, because I have a log minus a log. Why are they subtracted? Because again, we had division. So the square root of 3x on the top, y to the 4th on the bottom. So that would be the complete condensing. I think we got one more like this. Yeah. So again, start strategically. In the brackets first, and I guess it wouldn't hurt. Let's go ahead and move that 3 while we're at it. Log 4, 5 cubed minus, but now let's take care of these brackets. This x has a power, and why is this log 4, 6 being added to this log with the x? Because originally they were multiplied. The 6 and the x were multiplied. Just remember the x had a power. Okay. Now, 5 cubed, well, that's just 125. But now why is this 3 here? It was a power on this quantity. So we're going to have log 4, the quantity, 6x to the 7, raised to that power of 3. The 3 on the outside of those brackets, we've got to bring it back as a power now. Now we want to distribute this cube to the 6 and to the 7. So we're going to have log 4, 125 minus log 4. 6 cubed is 216. Now question, is that going to become x to the 10 or x to the 21? Remember, when you power to a power, you multiply. So it's actually going to be x to the 21. And then to finish up, you know, why are those 2 logs subtracted? Because originally there was division. So 125 and then 216 x to the 21. Okay, now we're going to change gears a little bit. There's a cool question that I get a lot when I take some college entrance exams, like the compass test, that is an application of the properties of logs. So take a look how these work. You're given log 6b and you're asked to approximate it, but all you're given to work with is log b2, log b3, log b5. So here's the name of the game. rewrite 6 using 2, 3s, or 5s. Keeping in mind that properties of log, we know how to break up multiplication, we know how to break up division, and we know how to move powers. So preferably rewrite 6 using division, multiplication, or powers. Well, lucky for me, I know that 6 can be 6 log, I need a b there instead of a 6. 6 can be written as 2 times 3. And I know to break up 2 and 3 into their own logs, I would break up the multiplication with addition. So I'd have log b2 plus log b3. And then all I have to do is simply add these decimals that represent these logs. 0.3562 plus 0.5646. What would that be? That would be 8. Carry my, so 8, and then 0, carry my 1, so that'd be 12, carry my 1, 9. If I did that in my head right, I should have grabbed a calculator. Double check that addition though. Okay, but that's all you have to do. Okay, here I have the 3 and the 2, but I have it as a fraction, 3/2. But that's no biggie. I know that to break up division, I just need to subtract log b3 minus log b2. Okay, so then I would take the decimal 0.5646 and minus 0.3562. And I'll leave you the subtraction just because I'm running short on time. Make sure you type that in your calculator, and no big deal whatsoever. Shouldn't be too hard. Okay, this guy. I want to get rid of the cube root house. So what I'm going to do, I'm going to rewrite 12 with a power of 1/3. Because you know the power is understood to be 1, the root of 3, so that would become a 1/3. And then we know that that 1/3 should come out front. So we would have equals 1/3 log b of 12. Now here's the dilemma. I got to rewrite 12 using 2s, 3s, and 5s. Well, what about this? 2 times 2 times 3. 2 times 3 is 2 times 2 is 4 times 3 is 12. Yeah, so then I can just break up that multiplication. I'll just have 3 logs that are added. We can handle that. Just notice this though. All 3 of those logs that are added, I'm going to put them in parentheses and keep that 1/3 out front. So it's going to be log b2 plus log b2 plus log b3. Okay, so then I would need to add these respective decimals. I'm running out of space. Well, I guess I should write it anyway. So 0.3562 plus same decimal, 0.3562 plus 0.5646. So add those decimals up, and then in your calculator, once you add that sum, multiply it by 1/3, and again, you'll get the final answer. I'll leave that for you because I don't have my calculator with me, okay? It's just a matter of plugging and chugging in your calculator. I think I'm going to stop there for my time. So, keep learning, guys. I will see you next time.